Welcome to today's webcast on developing with open source DBOS Transact for Python. Over the next 45 minutes or so, DBOS architects and co-founders Qian Li and Peter Kraft will demonstrate a much easier way to build and deploy Python backends, and in the process make them resilient to failures of any kind, make them fully observable, able to auto-scale up and down as needed, and make them much less expensive to run and operate. So without further ado, let me turn it over to Peter and Qian.
Hi, I'm Qian.
Peter.
So today we're here to walk you through key features and some demos about DBOS Python, and hopefully you can start building with DBOS soon. So as developers, you all know that building reliable services is really hard. I'm sure you've seen this because I see those very often. Like sometimes I buy a flight ticket, or I reserve like hotel or book some trips. I always saw those failures. And what's worse was that sometimes I pay for things, but I never received the order or I never received the item. So, well, as a customer, I was annoyed, but as a developer, I'm sure you'll feel very stressed and frustrated because you have to fix those errors and you have to handle them. You have to properly retry them. And oftentimes you have to fix some bugs and redeploy. So it's all super hard. So that's why we're here. So DBOS is here to help you to build reliable services at scale.
Yeah, so DBOS is a compute platform for building highly reliable applications. And the first thing it does is it helps make your applications almost crash-proof through lightweight, durable execution. And this part is 100% open source. It's in DBOS Python. You can pip install it and add it to your application right now to make it reliable. And what this means is that if you build your application with DBOS Python and your app is interrupted or crashes or restarts, when it restarts, it's going to resume operating from exactly where it left off. And every step in your workflows is going to execute exactly once. So it helps you make your applications much more automatically reliable and resilient to failures. And if you build your applications with open source DBOS Python, then you can deploy them serverlessly to DBOS Cloud. And this is a fully serverless compute platform that automatically scales your applications with no risk. So you don't have to provision resources. You can just push button deploy and your applications scale automatically with your load. And because it's a serverless platform, you only pay for the CPU time you actually use. So you don't have to pay for resources that you're not actually using. So how do you get started with DBOS? Well, you start by take a Python application, and particularly Python application that has a workflow in it. So you have one function, a workflow that's maybe calling several other functions, which are steps in the workflow. And a lot of applications are written in this style. You can think of payment processing, there are workflows in payment processing, workflows in logistics, workflows in ML applications, workflows in almost any type of business logic. And then what you have to do is you have to add lightweight annotations to your application. So tell DBOS which of your Python functions is the workflow, or which are the workflows, and which functions are the steps in the workflow. So you add these annotations to your code. And once you've done that, now you get durable execution. So now if your workflow is ever interrupted, if your program ever crashes or restarts mid-workflow, it will automatically resume from the last completed step. And I'll tell you in a bit more about how that works under the hood. And then once you've done that, once you've annotated your program, you can then deploy it to DBOS Cloud. And that's a single command that you run. And then your application is hosted live in the cloud. It's auto scaling, and it'll scale whatever you load you need.
Okay.
So we're going to demo a couple of use cases for you. First, we'll look at a payment processing use case, an online store use case, and then we'll look at an AI-powered Slack bot built with DBOS. But you can also use DBOS for many other use cases, such as data scraping, and we have customers doing this right now for data scraping, for reliable event processing, for multi-agent workflows, and for long-running interactive background jobs where a crash is really hard to recover from. So there are many potential use cases. So first, let's look at this e-commerce use case, this e-commerce demo, and we're going to start from nothing. We're going to start from nothing. We're going to start from our Cloud Console, and we're going to deploy the application from a folder on our machine, and then we're going to show you what it actually does. So I want to start from nothing because I want to show you how easy it is to deploy an application in Deboss Cloud. So all we have to do is drag and drop an application folder on a Deboss Cloud, and it deploys. And right now under the hood, it's zipping up your files, uploading them, and then automatically provisioning some resources on the cloud on which to deploy them. But the entire process takes about 20 seconds, and then you're live. And the application's hosted at this URL. Any of you can enter that URL. Any of you can go see this application. And the app, it's an online store. You can click through. It's a simplified mock-up, really. But you can click through it, and you can make orders. You can see that on the left, the orders like decrease your inventory, and the orders appear right here. But the unique feature of this online store, something that understandably most other stores don't have, is that it has a crash button. And what's cool about this is that you can press the crash button at any time for any reason, and the application will recover in a couple seconds. So we can be in the middle of an order, we press the crash button, and after a few seconds, the application resumes as if nothing happened. So we're in the middle of the order. We'll start another order. So we can see we're in the middle of one order, and there's another processing on the left. We'll crash. Wait a few seconds. Things are stuck now, but they're about to come back. And when they do come back, the order on the left keeps processing, and the order on our screen, we can keep clicking through as if nothing happened. So that's what durable execution looks like in action. Your application becomes so reliable that you can add a crash button to it, and it won't matter because you're going to recover through every crash. So now I want to show you how this actually works under the hood, what it takes to build an application like this. And it turns out it's actually not that hard. So first I want to show you the crash button because I want to convince you that the crash button really does crash your application. You press that button, it goes to a fast API endpoint, and that endpoint calls os.exit. So your application's dead. So now I want to show you what it takes to build an application that can recover from having this sort of code in it. So we'll show you the code for the checkout workflow, which is the main workflow of this demo app, and which contains most of the business logic and is doing most of the work. So this code is a workflow, like our previous example, but with many more steps. And each step is an ordinary Python function with a DBOS decorator on it. So here, the first step in our checkout workflow is creating an order. And we can actually look at the code for the step, and we can see that it's just, it's written with SQL Alchemy, and it's just a method that uses SQL Alchemy to insert a new order record into the orders table in our database and returns the primary key of this order as our order ID. So ordinary SQL Alchemy code annotated with a DBOS annotation to make this the first step in our workflow. And the rest of our workflow just continues to call the other steps you'd expect to find. So our next step is to try to reserve inventory. That's another SQL Alchemy operation, inserting a record into updating a record in the database. If reserving inventory fails, then we have to back out. So we cancel the order, and we notify the client that the order completely failed. If we did reserve inventory, then we can move on to payment processing. We send the client a unique payment ID so that the customer can move on to the payment processing screen. And then we wait for the customer notification that the customer has completed payment. And once payment is completed, we get a payment status. And if that status is successful, we can fulfill the order. That's the last step in the workflow. And if the payment failed, we can return our reserved inventory so we don't lose some inventory to canceled orders. And then we can cancel the order and then we're done. So every single step is a DBOS annotated ordinary Python function. And the entire workflow is just another Python function that calls those steps in order. And workflows can have any kind of conditionals or branches or loops or whatever other control flow structures you need to call the right steps in the right order. And the workflow has this annotation on top, so DBOS knows what it is. And this is all an open source DBOS Transact, all open source DBOS Python. You can add this to your own code. And now I want to talk a bit about how this actually works under the hood, how we guarantee that if your program is ever interrupted, it can automatically resume from the last completed step. So the way it works is that those annotations I showed you, like the dboss.workflow and dboss.step, they're wrapping each of your operations, each of your workflows and steps with code that stores the state of your program in Postgres, in your application database. So everything here is totally backed by Postgres. And so just to walk you through an example, when we start our workflow, when we start this checkout workflow, before it does anything else, it writes a record into Postgres saying that a workflow with this ID has just started. And because it's just started, it's in a pending state. So now we have a record in the database saying that we have a pending workflow with some ID. Then every time this workflow completes a step, we write another record to the database saying what step executed and what was the output of that step. So when we reserve inventory, you write a record saying, okay, step 1 was reserving inventory in this workflow, and the inventory successfully reserved. Then we move on to processing payment. Then we write, so when that completes, we can write another record saying that, great, payment completed, the step 2 was processing payment, and that completed successfully. And because we have all these records in the database, if something goes wrong, if there is a crash or interruption, then normally that will be bad because we've paid for something but hadn't fulfilled the order. So we might lose a customer payment. A customer might have paid for something they don't get, or we might have to have somebody go manually dig into the database and update things for the customer once they find out about this mistake. So normally this sort of interruption would be very bad. But in DBOS, because we have these records, when the program restarts, it can see, well, there's this pending checkout workflow. And this workflow has successfully reserved inventory and successfully processed payment. So we can recover this workflow to the next step. And looking at its logic, the next step is fulfilling the order. So we can recover this workflow to fulfilling the order. We can execute that step normally with all the inputs we already know. And then once we've done that, the workflow is done, the workflow succeeded, so we can mark the workflow as successful and move on. We're done successfully processing this workflow.
So now you've learned how DBOS works, and let's move on to our second demo app, which is an AI-powered Slack bot. I know everybody has a Slack bot, but I still want to show off that we have an awesome bot in our Slack channel. And I built this a few weeks ago, and our teammates have been playing around with it. So what it does is that if I type in some information, let's see, my favorite fruit is, say, pineapple. Under the hood, this Slack will send an event to my bot, and my bot will, upon receiving the event, it will contact OpenAI using the embedding model to turn my message into a vector, and then it will store my message along with the vector into a Postgres database. So my bot will have memory. So it remembers everything happened in this channel. And then when I ask a question, what is my favorite fruit? The bot will leverage both the recorded vectors, and also it will leverage LLM. In this case, it's OpenAI like Turbo 3.5 model to answer my question. And what's awesome is that the bot orders the messages based on timestamp. So if I say, actually, my favorite fruit is apple. And if I ask the question again, what is my favorite? Well, the bot will see my latest changes. My latest favorite fruit is apple, so we'll return it. So, okay, it's a funny bot. It's not super smart sometimes. For example, it doesn't really count. When I ask it to count to 5, it will count to 3. So I'm not an AI expert, but I know how to build a reliable AI bot. So if you know how to make this bot smarter, please do let us know. All right. So now I'm going to dive deep into how I made this bot work and how I made it reliable. So the story behind this bot was that I started with an off-the-shelf RAG demo, actually from Llama Index, a popular AI framework. And well, basically everyone has their own RAG demo. I picked it because it's popular. And all demos are super cool. And you can use AI for basically anything. You can use AI to like read your documents. You can use AI for chat. You can use AI in any field you like. So, but no, the issue is that no one tells you how to take your RAG application and put it into production, how to make it scale, how to make it reliable. So that's where I'm so excited about Deboss, because Deboss can help you. It can help you reliably deploy an AI application to the cloud. So here are some specific problems you might run into when you develop a production AI application. So first, you need to find a way to host your app on the cloud. So when I follow the original demo, I had to run it on my laptop, but it's not very reliable because I want to share this bot and want people to use and interact with it. So I need to find a cloud platform. And you also want this cloud platform to be that's priced fairly. So for example, a common problem we've heard from people is that if you deploy this app to, say, AWS Lambda or EC2, you're actually paying for the compute time when your bot is waiting for the responses from OpenAI, which can take like from seconds to tens of seconds. And then the second problem is that if you are building a Slack bot or any other bot or any kind of AI application, you have to deal with timeouts and potential retries. So you typically write a webhook, and your webhook will typically need to respond to either Slack or other services within, say, 3 seconds. And if you don't respond, then Slack will assume your app failed. It will send the same event again. So now you get duplicated events. You also have to handle that correctly as well. So it's kind of tricky if your Slack bot has higher traffic, or if you're using some models that could be slow. And finally, we've heard constantly from developers complain about the rate limiting from those AI platforms. So for example, if I use a more expensive model on OpenAI, I may get rate limited to a few hundred messages per, a few hundred requests per minute. And if I exceed that request limit, or sometimes OpenAI will just randomly rate limit my request, it will respond with an error code. And in this case, those are not real errors, so I have to correctly retry on errors. And this is annoying because you have to manually basically build those code. But with Deboss, we make your life easier. So let me show you the actual code behind the Slack bot I just showed you. I'll first show you the dispatch code for when it receives every Slack message. And then I will show you the workflow that durably orchestrating the RAG pipeline for each message. So first, let's take a look at the Slack dispatch code. So in the original demo, like most of the AI demos, it synchronously runs the RAG pipeline for each message it gets. So this is a common pattern. It's a common problem for those AI demos. This pattern, this synchronous processing can cause problem in production because it can easily time out if the LLM call takes more than 3 seconds. And the original demo also doesn't have any deduplication method. So if Slack sends you an event or message twice, you will get duplicated responses in your Slack channel. And those are kind of classic problems when you're trying to process events reliably. And so how do you do it with Deboss, right? So you can see this in this code. We start the workflow in the background using deboss.start workflow. So for each request, we start the workflow asynchronously. So the workflow will be processed in the background for each request instead of processing it synchronously. So we can avoid Slack timeouts. And then in the background, we rely on Deboss reliable and durable execution to guarantee that for whatever workflows we have started, they will always run to completion. So it guarantees that whenever we receive a message from Slack, we'll always either store it to our vector store or we'll respond back to the Slack channel. And then the second thing I want to point out is that we use the unique event ID from Slack as an idempotency key for this workflow. So under the hood, Deboss guarantees that each event is processed exactly once. So even if there is a glitch from Slack where it sends multiple events to Deboss, the response workflow will only be triggered once, and you will always only see exactly one response to your Slack channel. All right, and now let's look at the actual workflow behind the scene, right? So actually this workflow I took the workflow from the original demo, and all I did was to add the Deboss workflow and Deboss annotations to the workflow itself and to each step. So what it does is that it first checks if the message is a question for the bot. And if it's a question, then it will first get the answer from by querying the LLM or querying the Llama index, and then post the Slack response to the channel. So if the message is not a question, the bot will embed it as a vector and store it in the Postgres database. So this workflow is straightforward. It's kind of mostly unmodified from the original demo. All I had to do was to add a Deboss workflow. And then for each step, for example, in this answer question step, I copied the original code and which basically queries sends the query to Llama index. And then I added a deboss.step annotation on top of this function. So originally, if any error happened in the middle of this function, then basically you will fail processing the Slack message. But with @deboss.step annotation, Deboss can correctly handle the error and retry if necessary. All right, so today, well, we've shown you some core features of Deboss, including how you can use lightweight durable execution to build your app, and how Deboss enables exactly once event processing, and how after writing your code, how you can easily, with one command or with drag and drop, you can deploy to Deboss Cloud. So there are other kind of cool features of Deboss, which you can explore on our website or our docs page. That includes like automatic workflow tracing, So DBOS basically emits open telemetry format for tracing and logs. And then we also have scheduled jobs. So in some of the demos in our website, you'll see that you can have a Slack bot scraping hacker news and send you updates every hour. It's super fun. And finally, there's a unique feature called time travel. We don't have time to cover it today, but it's super cool. Make sure you check it out. And our DBOS team is actively working on some user requests, some cool features, and they will be available in the next few weeks. That includes job queues, async IO support, and also database trigger events. So whenever you, it will allow you to monitor changes to your database tables. And for example, if there's an insert, it will be able to trigger a DBOS workflow exactly once. All right. And we have an awesome examples page. Please take a look and explore more examples there.
Thank you, Peter. Thanks, Qian. We do have some questions from people, and let's start with this one. Do you need DBOS Cloud to run your applications?
No. So DBOS Python, DBOS Transact is 100% open source. All it needs is Postgres. So you can take these annotations, you can add them to any Python program, and it'll all completely work locally. If you've done that, then you can deploy your application to DBOS Cloud, which gives you serverless hosting and so on, but you don't have to. It'll all work locally.
Related to that, they also were wondering where does DBOS Cloud run? Where's it hosted?
We currently host it on AWS. Yeah.
Okay. Here's a good one. Somebody asks, it seems that DBOS is write intensive, for write intensive applications or transactional applications, but also maintaining state information. And the question, given that, the question is, what makes it scalable when traffic to the application increases?
Yeah, so there's a bunch of optimizations under the hood to reduce the write intensiveness. The biggest one is that if your application is writing to the database a lot, DBOS will piggyback onto your existing database writes. So it'll do its state updates as part of your existing database transactions. And that can greatly reduce the number of writes that DBOS has to do because it's doing them as part of existing writes. And then there's other optimizations like not doing writes for functions that we don't have to do them, not doing writes that aren't necessary because the functions are read-only and related optimizations.
Yeah, I think in computer systems, common optimizations are like batching and pipelining and asynchronous processing. So we have all those optimizations in DBOS Transact.
Is it good or bad practice to use the same database for other application data?
Yeah, so the main goal of DBOS is to bolt on the durable execution records into your existing database. So like basically DBOS will add additional tables to your database to record like what have been executed and to remember state. So we think it makes it really lightweight because you don't need a separate data store. But like, if you like, you can bring in you can have multiple data stores. You don't have to use a single database.
Yeah, but like that's like what our customers are doing in production right now is using DBOS using DBOS writing to their production database with everything DBOS writes is isolated in the DBOS schema.
Yeah.
DBOS uses the Postgres schema for isolation.
Thank you. Is there a time/compute limit for applications running on DBOS Cloud? The reason they ask is that AWS limits Lambdas to 15 minutes.
So no, this is actually one of the strengths of this architecture. So DBOS Cloud supports really long-running workflows. So you can, for example, have a workflow that maybe sends an email and then waits potentially days for the email to respond. And it can do that because the architecture is optimized for IO-bound applications. So you're only charged for the CPU you use. And if your applications is doing very little waiting for an event, then you're not charged. So, optimized for IO-bound applications, charging for CPU usage, and really deep built-in support for ultra long-running workflows. give you an example. One cool thing we have is durable sleeps. So if you call a sleep in Deboss, this is just an example. If you call a sleep in Deboss, it doesn't just call Python's time.sleep. It stores your wake up time in the database. So if you do a sleep 1 week, because maybe you want to wait a week before sending a follow-up email or notification, then Deboss will record the wake up time in the database and then put your application to sleep. And if your app is maybe restarted during that 1 week long sleep, when it restarts, it'll look up the original wake up time in the database and wait for that. So you can just put a dboss.sleep 1 week, and your application will sleep 1 week, no matter what happens in the interim. And then when it wakes up, it'll do whatever you told it to do.
Okay, thank you. Wondering whether data written to Postgres is encrypted or not?
Yes. Well, I think it depends on the setting. So if you are using the database, if you are using a database we provide, then we encrypt everything. But if DBOS Cloud also allows you to bring in your own database. So if you bring your own database, you are responsible for encrypting your data.
Are there features that you only get when the app is deployed on DBOS Cloud? I guess, like, what's the difference? What do you get by deploying on DBOS Cloud versus deploying on your own?
Serverless scaling. If you deploy to DBOS Cloud, then it will manage your application's hosting. It will guarantee that it'll make sure your application remains available. It hosts your application, and it does so in a way that's truly serverless. You don't have to worry about provisioning. It auto scales up and down based on your load, and it charges you only for the CPU time actually used.